Jesus Christ with 12 of his disciples. They all had their dinner before somebody compromised Jesus Christ to the Romans. So he's very famous for that. He's like one of my very favorite people, not because of those paintings, but he's like a jack of all trades. He was a renowned painter. He was an architect. He was a sculptor. He was an engineer. He was a scientist. You name anything, he has touched upon all of those things. A lot of the scientific community actually credits him with the first sketches of flying machines, helicopters, airplanes. And the legend also has it that he invented armory. Armory ante, you know, all these defense tanks and all that, right? So a lot of the fighting techniques were invented by him. So he's a jack of all trades. So look him up. You'll be inspired by him. Okay. What else? Questions, comments from last few classes? Please feel free to ask me while we are waiting. I'll wait another couple of minutes for JNTU Vijayanagaram. They're having some internet problems. Aditya Engineering College, everyone is there, but I don't see their video. If the video is enabled, you can certainly show the video. Okay, good. The people sitting in the back row, I want you to come and fill the front rows, please. Only when the front rows are completely occupied, you can go sit in the back. I'm looking at all the girls sitting on the right side, to my right, in the back rows. I want them to come forward. 3, 4, 5 girls uన్నారు అక్కడ. 5 or 6. Okay, excellent. Okay, Aditya Engineering College, I see all the uniform girls there. Excellent. Is it really uniform or you all come like that? I don't understand that. Does an engineering college have a uniform scheme? Never heard of that. Okay, I think we have quorum now. Administrative details. Some of you missed the class last week. The midterm is coming up. Murthy Garu and other faculty members are going to, I think they decided on October 12th, if I'm not mistaken. Open book, open notes. You'll all be doing the exam in teams of 2. A lot of problem solving. Now, all the girls, tell them to come forward. Can you tell them? Ask them to fill up the front row seats. Excellent. Okay. So if I were you, I would start reviewing all the slide decks and all the stories that we discussed and all the discussion that we did. A lot of Murthy Garu's wisdom added to the lectures along with other faculty members. So you may want to start finding the right team member because the grade is given to both the team members same, right? So you start negotiating who the right team member is for you. Okay, great. Let me share my screen. Okay, so what we'll do is today we'll get into an interesting aspect of modeling called the behavioral model. Remember the 3 things that we always need to know when we are building systems: users, use cases, and data. So once we get the use cases and all that, ultimately how those use cases are performed, right? There's a sequence, there's an order. in object-oriented technology, one of the things that we call is, let me annotate here, show the particularly, I mean, most of these things that we're learning tend to be, they fall under quote unquote object oriented way of doing stuff, right? So most of the behavioral models ultimately you have to answer when we are analyzing and designing, we say who does what at what time. Now somebody is doing something, what time indicates some dependency and time sequencing and so on. So all that functionality is the behavior of the system. So behavioral models capture them in certain ways. There are so many different types of behavioral models. Even if you talk about sequence diagram, that's in essence showing a behavior, right? So we'll formalize some of the discussion here. And if time permits, we'll get into the next chapter, which is about architecture. Okay. Why it won't let me go there? Okay. Okay. So I say they capture the dynamic behavior, meaning there's a certain order, there's a time sequence, and these behaviors happen because something triggers that behavior, and the object performs certain actions and then produce some output. Okay. So in essence, they show what happens or what is supposed to happen when a certain external stimuli comes from the environment. Okay. If you recall from a few weeks ago, I showed you a process model from my work environment where I showed you swim lanes, right? And I showed a black shaded circle saying that is the starting point. That means somebody sends a request to my office and when we do certain things. So we show that stimuli and what happens. Okay. Now the stimuli can happen in two ways. One is data driven. Okay. And if you recall, Murthy Garu talked about data flow diagrams. As part of our interactive discussion, he alluded to data flow diagrams. So most of the data driven stimuli, when we show that, we use data flow diagrams. Now it doesn't have to be only data, it could be events. Somebody sends a message, that's an event, right? That also can trigger some processing. Okay. I'll move a little bit fast here. Okay. So most often, a lot of business systems that we are talking about, they're heavily involved with data processing. For example, let's say insurance applications, payroll applications, registration systems, scheduling systems. Most of them are very much data driven. Okay. So what they show is a sequence of actions in processing the input data. And after they process the input data, they generate some output. Okay, so you have to model that in some fashion. Okay, and as it says here, comes in very handy during the analysis of requirements. Okay, now I do want to put a caveat here. Remember, I told you I very rarely use data flow diagrams when I'm doing requirements analysis and all that. I might actually let me modify my statement there. I may use it for my own understanding, but I would not show the level of detail of data flow diagrams to a client. Because the data flow diagrams in theory, we go like 3 levels deep. I assume you learned something about data structures and all that, right? There you learn about hierarchy and all that. So in data flow diagrams, most often we build a big hierarchy. Pretty confusing if you do that. Okay. So here is an example. Remember our, I'm getting some static. Somebody is, I have to mute somebody here, hold on. Good morning, Gudlavaleru, and good morning, Vijayanagaram. I'm muting you. Good morning, Andy Thirumal Rao garu.
Good morning, sir.
Good
Very good
morning.
morning.
Very good morning. Let me mute you. Okay. So here is an example in that medical example that we're taking, right? Insulin pumps operation, how it operates. Did I? 1 second, hold on. Yeah. So I won't go into the gory details here. But you can see here the blood sugar sensor gets the value, that is the data, and it computes the sugar level. Now looking at this picture, there are two different types of boxes that are being shown. Pay attention to that, right? One is rectangular with perpendicular lines. The other one is curved, right? So based on this, I can say one is the data and one is the action, meaning some activity function is being performed. Okay. So if you say get sensor value, to me it denotes function. Next to it, if you see sensor data, that means you're actually getting the data. So the rounded edges one are the actual functions and the square boxes are data. Okay. And then this is how the function, the insulin pump works. Now, if I give the same example to different teams, they'll all come up with different data flow diagrams, right? One person can break the functions to a lot of smaller functions and show them as separate boxes, whereas another team can combine multiple functions to one and call it one big box, right? So the abstractions that you use in coming up with data flow diagrams vary significantly. Now, typically, if you were to use data flow diagrams in an industry-oriented application, as mentioned a few minutes ago, you don't really create one huge data flow diagram. You start with a higher level of abstraction, then break each of the boxes down into smaller functions. So you build a hierarchical model of data flow diagrams. Okay. In my class, typically, after my first few lectures on that, I stopped using data flow diagrams. It's just a personal bias for me, but if you are comfortable drawing data flow diagrams, that's absolutely fine. Okay. Now here is a flow diagram, which is more like what we have seen in the past, right? Like a sequence diagram, right? So you have some kind of an order processing, right? Let's say you place an order on Amazon. You go to Amazon, you place a book order. What happens? Right? Same thing from your college, you call up your stationery vendor and you place an order for a lot of notepads and pens and pencils and all that, right? So there's a certain way in which that flows. So obviously the way you read this picture is, as we noted in the past few weeks, you go from left to right and top to bottom. Okay. Now, what happens if you have these event-driven systems where there's not much data? Here is an example of a phone line, right? Phone switching system. They are basically you're modeling all the events in the system. So event becomes the trigger. Okay, like here he gives a very good example here, right? If I were to use my annotation here, there's a highlighter here somewhere. See this one here, for example. This is in WebEx, the annotation is quite primitive. If you use my app, it becomes better. But So here the event is what? Picking the phone of the dialer. Okay, obviously no one is doing this now, right? It is all about cell phones. There is no picking the dialer and all that stuff like that, right? But when you do that, it creates a dial tone. So in our cell phone, what do you call it? You say place a call, right? You click, you dial the number, and then you say call, then you hear the dial tone. So it's basically event driven system. Okay. Now, one of the famous models that we have in these event driven systems is this finite state machine diagrams. Okay. So how does a state machine work? I'm assuming, or maybe I do not know if I'm making a incorrect assumption here. You would have learned about finite state machines in one of your classes by now, right? Show of hands here. How many of you know how to draw state machine diagrams? I'm looking at JNTUV here. You can raise your hands if you know how to draw state machine diagrams, finite state machine diagrams. Oh, by the way, Tirmal Rao Garu, I asked JNTU Kakinada, all students should come and occupy the front row seats. Excellent. So state machine diagrams, I think, I do not know, probably I learned it in the first or second year of my electronics engineering program when I was, but since you all kind of learned about use case modeling and all in some other classes, you probably would have learned about state machines. So the states, the nodes are the states and the events are arcs between those nodes. So what does it mean, right? Okay, I did not see anyone raising hands from JNTU Vijayanagaram. What about JNTU Kakinada or Gudlavaleru? Have you been exposed to? I see one or two students raising their hands. Let me unmute you. Cheppandi. Tirumala garu, speak now.
Yeah, the JN.
Finite statement. Okay, excellent. So who said that? Ask them to be ready to draw one now. Okay. So I'm going to do a small exercise here. So if I'm putting it in a different mode here. What about Gudlavaleru and JNTU Kakinada? You can put it in chat if you have learned state machine diagrams. Machine. Okay. So what would be the state machine diagram for a vending machine operation? Remember, we use this for dynamic behavior. Okay. So first, we are capturing. Cheppandi evaro maatladutunnaru. So this is used for capturing dynamic behavior, right? So I will draw the, if I have to draw the initial state, let's say I draw an initial state here. Koncham time pattundi because PowerPoint is not really. Okay, start, I'll use color, black, okay. So that is my start state. So tell me what are the states that a state machine can be in? I always take the easy one, right? What is the event? So start state and idle state. I should not even say start. Sorry. Let me call it. Murthy garu will point out the mistake if I do not correct it, right? So I'm in idle state. That means the state machine is waiting there. And what did we say the behavioral model? Some external event would trigger the activities, right? So there's some stimuli or stimulus. There's a stimulus to this entire software, vending machine software. What is the stimulus to a state machine? This is a vending machine. Remember, forget, don't call it state machine, call it vending machine. Okay. So what is the stimulus to a vending machine? Which student can answer that? That deserves a Kit Kat. Now let me ask you another fundamental question. How many of you use vending machines in your college campuses? Are there vending machines in college campuses? That's a question to the faculty members. Are there vending machines in college campuses? But even if they are not there, but there are vending machines in your movie theaters, right? No. See, Chakravarti said there are no vending machines in college campuses. No vending machine in Aditya College. Okay. So no wonder that's why students do not know the behavior. Okay. But you would have seen vending machines in movie theaters, big malls. See, Chakravarti was saying big malls. All of you would have gone to malls, right? So what is the event? Let me draw a line here. Okay, line ekkada idi. Okay. And I will annotate it. I'll write text too. Edit text with ikkada. Okay. Okay, you see my screen there? Okay, coins in. So when I go to a vending machine, let's say I want to get a cup of coffee. Then I put a coin in there, right? To begin with. Okay, so that is the stimulus. So you are in an idle state. Some external stimulant, meaning the user has gone and they put a coin in. Immediately the machine is no longer idle. It goes to a next state. So what is that next state? Let me control C, control V there. I say collect money state. I'm just using my language here, right? If some other person would have said compute balance, it doesn't matter what it is, right? So what does collect money state mean? The idea is, let's say the coffee costs $1. I put 25 cents using American cents and dollars terminology. So in that state, I would compute the balance and then I'll continue to collect money. Correct? Because I cannot, if the guy puts 25 cents, I cannot dispense an item which costs $1. I'm going to collect money until the total is greater than $1. Okay, it's greater than or equal to. Okay, if I say greater than, then when I do my design analysis, they would point out a mistake saying it should not be greater than, it should be greater than or equal to. Okay. Okay, got it. Now, once I go past that, then I would have to go to the next state. What is the next state? Somebody is talking there. Sorry. So I go to the next state called ask the user to make the selection, right? You have coffee with sugar, you have coffee with milk, you have coffee with sugar and milk. You can choose mocha, cafe latte, right? All that selection. See how I am developing the behavior of the system to be built. Mute Funny Krishna. Okay, let me see Funny Krishna Garu here. Hold on. If I can see him, I can mute him. Okay, I muted Goodlavaleru. Funny Krishna. Okay. Okay, I muted them. I muted Ideal also. Thank you. Welcome, Venkateshwara Engineering College. Okay, Funny Krishna from Srikakulam. Okay, great. So now, students, let me ask you this. Do you see how I am developing the state machine? Let me pause here and give you. To me, state machines are just as important as knowing how to come up with entity relationship models. Because entity relationship models capture your data and state machines capture your behavior, dynamic behavior. Ultimately, the developers need to understand the dynamic behavior to write proper code. Correct? So it's important for you to understand this. Now, what is the practical reality? How many of my teams have drawn state machines in most of the projects that I have led? We do not come up with state machine diagrams. It could become tricky. It's complex. You need to have a good grip on the subject matter to come up with state machines. But whenever I'm discussing with architects and my fellow architects, we definitely come up with the dynamic behavior, modeling of dynamic behavior like this. We use state machine diagrams or we use swim lanes. If you recall my swim lanes that I showed you, that was also a state machine diagram only, except we no longer call it state machine. We put some swim lanes and all that to make it more palatable to the user. Swim lanes essentially capture the dynamic behavior. Okay, but if you're comfortable drawing state machines, it's a good thing to have. Okay, let me go back to my presentation mode here. Okay, so here is a big example of how a microwave oven works. Almost all of you in India now have microwave ovens, right? So you see the blue circle here on the left, shaded circle. That is the idle state, meaning they're waiting. All it is doing is showing time. All microwave ovens have time. Okay. And then the user will perform action, half power or full. Without being picky here, I would grade the state machine diagram a B grade, not an A grade. Why do I say that? Anyone knows why I say that? Okay, so notice something here. You are basically making an assumption that the user would select full power or half power, right? Believe me, I have been operating microwave oven since I came to this country 30 years ago. Power is always there. So power, selecting full power level is an optional thing. Whereas here, this state machine diagram tells me that the user always has to first select half power or full power to begin with, right? Unless I select it, I cannot move forward. So in that sense, I'm just nitpicking, but it at least gives you an idea how it works. So you select full power, you go to the top. Then the user, what does do mean? Do mean the user is setting the power to some 600. Then you get into the next state called set the time. Because I keep pressing digits, right? If I have to do 2 minutes, I say 200, it says 2 minutes. So you are in that loop, that is that number loop you see here. Got it? Okay. Now, one of the things I want you to know is even the best guys who know how to draw state machines, they'll not get it right the first time. Most of these diagrams, nobody gets it right the first time. That's why I call it a working set. You keep drawing it and then you refine it, you evaluate it, you keep changing it till you think you got it right. Okay. Never be under the impression that now, if it acts as any motivation for you, I can guarantee you that in the midterm, I'll have a question where I will ask you to draw a state machine diagram for whatever problem that I ask you to solve. In case you're thinking we'll just listen here and then we'll forget about it. Nope. I'll be asking you a question on that. So I do not know how much percentage of the points, but it'll give you an opportunity to demonstrate your knowledge on that. Okay. Okay. I'll proceed forward here. There's a more detailed example here, so I encourage you to study that and send me questions on this if you have any, because there will be definitely a question on this. Okay. So he shows all the states. Okay. The next section is really model-driven engineering, which becomes too theoretical and boring for this class for now. So I'm going to be skipping this model-driven engineering, but I'll just say one or two brief sentences around it, and then we'll move on to the next chapter. Okay. Programming, right? Way back in the 1940, I think 1945 is when we got our first computer. Anyone knows what the first computer name was? You must have studied that in computer architecture class. Does this, I think if I remember right, it is called ENIAC Anukuntanu, if my memory serves right. It's an acronym, something for enumeration, something like that. But you can Google up ENIAC name, if I'm not mistaken. Okay. But what it is right, we always wanted to, our ultimate goal is what? The machines should produce the code. Human beings should not write code. That is the holy grail of programming. Okay. Holy grail is a term that we use, right? I'm assuming you know that. Holy grail is like the ultimate. మన ఇండియాలో ఉంటారు అది ultimate అంటాం in our language is the ultimate thing, right? Like how Shah Rukh Khan is the ultimate movie actor. We say is right. If we can generate the models, that's what model driven engineering is, right? So if we can generate the models out of our analysis and feed that model into a compiler, automatically the code comes out. That's what is happening today, right? If you really take a UML tool, like a rational RUP tool, rational unified processing tool, when I create the class diagram and the use case model, the system actually generates all the framework of the code. So when I an object or class called faculty, I actually see class faculty. And then if I show the inheritance tree, it shows where it is inheriting from and all the methods. Remember in the use case models, we also show the functions, right? The function templates. So it creates the function template. It puts all the parentheses properly. I just have to go fill the business logic there. Okay. So when you get into model driven engineering, you will learn things of that nature. Okay. It's too early for you to appreciate this one. Here. Okay, I have to turn off annotation. In WebEx, when I turn on annotation, I cannot go forward with my slides till I turn it off again. Okay, now it is letting me, okay. So there are some pros because we are dealing with higher levels of abstraction, that's a pro, and then generating code automatically. Very nice, right? That means more we'll not have use for programmers. Okay. Now you can see the cons. The abstract models may not necessarily be right. Okay. Cost is there, and developing translators is never an easy task. Imagine it's kind of like this. Why are application programmers? I can get a lot of application programmers at a cheaper cost compared to people who actually develop the tools. Like imagine somebody working at Microsoft on the Microsoft Office suite tool. That guy is earning more money than somebody who's writing a registration system for me. Very challenging. Okay. Okay. There's some examples, but I'm just skipping it. So here are some of the key points from our this chapter. We started off with what a model is. Some of you have helped me with the definitions of what a model is, right? If you recall from several weeks ago, it's basically an abstraction of a system where we focus on the relevant characteristics. Okay, there are a lot of characters, but we focus on only the relevant characteristics as it pertains to our application. Okay. Then we have the context models, right? That is where it goes by different terms like context, domain model. We gave an example of a context model. If you're dealing with, let's when you draw a context model, we said that student registration system should be interacting with the financial management system, because when students pay fee, that fee should be reflected in the financial administration system or financial management system, right? So that is where the entire domain model or context model comes into play. Then we went into use case models where we came up with users, use cases, class diagrams, sequence diagrams, activity diagrams, right? And then we also discussed structural models where we talk about the architectural components of the system. Today we talked about behavioral models where we capture the dynamic behavior. It could be captured using techniques such as data flow diagrams or state machines or sequence diagrams. Okay. Okay, let me pause here. Questions, comments? How many of you feel confident for the midterm? If I were to give you a midterm today based on the chapter that we have learned so far, how many of you think you will score above 90 points? Nobody raises the hand? Come on. You know, my dad always used to tell me, even when you so I expect each one of you to raise hands, you will score. Sir, you are insulting us, we'll score 100 out of 100. Okay. Yeah. So pretty easy actually. As the quote is really so apt, right? Da Vinci's quote: "Simplicity is the ultimate objective," right? So if you understand the key concepts, you really don't need to memorize anything there. Okay. Okay. So I'm going to take a 2-minute break here with your permission to get my tea and open up my next set of slides. Next chapter. Let me open the slides here and then I'll get my tea. Because after architecture, we get implementation and testing. And after midterm, we get into all the specialized topics. So let me open this up. I'm still sharing my screen if I'm not mistaken. Okay, so while I go get my tea, if you have any questions, just put it in the chat. I will answer those questions and then we'll jump into this chat. Preparing for your midterm. Okay, Murtigara, I'm taking just a 2-minute break to get my tea, Andy. I am back, but Chappan Murtigar, you are talking to your students or? You are a little bit quiet today. Great. Okay. No questions. It's everything too easy. So one other administrative detail. Yesterday I was at Cisco talking to a good friend of mine. He's an architect there, IT architect. Mani Kashi Vishwanathan. Long last name. We just call him Mani. More than somebody has having a problem with the microphone, but that's okay. We will, by the time after you fix it, you can talk. Um, so I was telling him, because when I teach, right, even at Berkeley, to come and give a guest lecture, like we call it like fireside chat, right? Because this guy Mani has implemented uh, so many learning management systems inside Cisco, uh, which are internal, external, hosted, SaaS vendors, all kinds of combinations, right? So as an architect, we have to deal with so many issues interfacing with external vendor. How do you authenticate the users, right? What are the authorization rules? How does the data flow from an external system to internal system? How are employee records updated? What are the security issues? One of these sessions, and then we can bombard him with a lot of questions. Sounds like a plan? But it's very boring to listen to the same faculty member over and over again. So, okay. Questions from Aditya Engineering College. Go ahead. You can either talk or I'll unmute you. You can talk or put it in the chat. By the way, don't put it in private. You just put it in for everyone. So that way they know that questions are coming. So when I went to my microwave to warm up my tea, I was I was reflecting on our example. No, I did not press the power level button at all. Chappandi Aditya, what's your question? I cannot hear anything from Aditya. Okay. As far as project is concerned, okay. So Aditya the question from Aditya is, as per the project, the group project that you do in teams of 4, what diagrams are needed to specify, which are important, right? Um, I'm just thinking which way I should answer that question. The way I say that, right? It's a good question. The reason if you see me smiling a little bit is, right, I want students to tell me what diagrams are relevant. And the goal here for the students is say, okay, we are the users of the tool. So what they think are the relevant things. So at the very least, I expect the students to say, to give me a use case model. I can actually write here. Why am I writing there? Let me, yeah, I can write it in the, yeah, let me write it here. Sorry. So for the project, right? First of all, of course, I need a problem statement. Okay. Then to show that they have a good grip on what they're trying to do, I want a use case model. And I'm even defining what use case model is for me, right? L పైకి వెళ్ళిపోయింది అక్కడ. Forgive me for that. Okay. See, I screwed up annotation. See, the WebEx annotation is a little. Okay. And I would also ask for a domain model. Also known as context model. I will make them model the data through an ER diagram. I will ask them to capture dynamic behavior. Or activity sequence diagrams. If somebody is daring enough, they can do state machines. I'm not saying they have to do all the diagrams, which of them they feel comfortable with. The idea is to demonstrate their understanding of the problem domain that they're trying to solve, right? And then they are going to show the system architecture, which we are learning now, right? Okay. And then hold on 1 second, please. 1 second. Sorry for a 1 minute interruption, Andy. I'll be back. She wanted me to fix her dinner. And today I told her I am going to make her nice veggie burgers. So sorry about that. Okay, so you get the idea. For implementation, what I want is some kind of a hard-coded. I shouldn't say hard-coded. Why don't I call it prototype? Prototype. Okay, prototype can take, it could be HTML or PDF mockups. System functionality. Why should we, then the question asking, why should we need to draw modeling diagrams even after developing our project in some language? Because I want them to get experience, and but I don't want them to get into the habit of writing code without going through these diagrams, because ultimately the purpose of the diagrams is to have communication diagrams. What they understand is the mockups. So what we typically do is when we have a problem statement, we get a sign off on, we call it concept commit here in the industry, right? By saying, hey, this is our understanding as to what you want. Am I correct? Then you sign off before I go and build an architecture for that, right? So the kind of tools that we use to do that is ER diagrams, swim lanes, and then users and use cases. Very simple, right? So for a 1 to 2 page problem description, by the way, all of these things that are listed, you can finish them all in using the agile method. So to follow. Got it? So it's for practice. Okay, great. So let's get into now actually talking about the project. I hope the project teams are formed. Only one college sent me the full list of all the project teams. I think that was Goodlawaleru Engineering College, which sent me the list of project team members. We should finalize the problem statement and all that in a week or so. Otherwise, you will run out of. So questions, are students scared? You should not be scared because this is your time to shine, right? The projects are for you to shine. Okay, so let's get into this wonderful section called architectural models. I'm going to remove the annotation now, so that way I can go to this. Okay. So we'll talk about this design. So let's look at what kind of things we do here. If you saw a young lady, architecture, we kind of touched upon it even on one, right? So how do we organize the system when there are many classes right? Let's say it's not uncommon to show 100 classes in a typical software system. Very hard to understand just a simple class diagram, right? One level class diagram which shows 100 classes. Anything, right? Anything where it goes beyond 10 things, it's very complex. So you have to break it down into typical standard software engineering says you have to software. How can we organize it? So once you organize it, you start showing some boxes to show here is a UI subsystem. Here is a financial system. Here is a registration system and so on. So that is organization. Okay. So who does that architectural design? Typically, they are known as lead architects, right? These are not the fresh out of college programmers, because these architects have enormous knowledge of implementing tens of systems, if not many more. Is all of that experience is what makes them an architect. Okay. Um, Typically in the industry, if you have worked on good projects for 5 years, you can claim yourself to be an architect. Who gives the architect designation, right? If you are an independent consultant, one fine day after 5 years, you say, I'm an architect from tomorrow onwards. As simple as that. Okay. So we'll see what kind of things. So you can see, remember we talked about agility, right? So generally accepted that an early stage of agile process to design an overall systems architecture. Okay. That is what agile robot control system. Okay. We all understand robots, but you can see here, I'm assuming you have seen some robots. At the very least, you must have seen Rajnikant's Robo, right? They call it Robo. We call it robot here. They call it Robo there, I think. Okay. So as you can see, any robot control system would have these various subsystems, as we call them, right? You have a vision system because robots cannot operate without vision, usually. Okay. And then the systems, how do we identify gripper? Let's say if the robot is let's say there are robots in hospitals here where they deliver breakfast to patients every day. You must be surprised to know that. But believe me, it is absolutely true. There are robots where they are programmed, they go deliver breakfast to patients in different rooms. So they have to grip cups, they have to grip trays, right? So like that, you come up with different architectural components. This is really not uh, it is still an art. The thing that we joke about is when you are building a system, you get two architects in the room. What do you think they would do? You have two architects in a room. What do you think they would do? You know what they would do? Do you know this story about Jayprada and Sridevi? Murthy garu cheppandi. You were saying something. Okay, you're not saying anything. they don't talk to each other like Jayaprada and Sridevi in a room. Okay. So what it means is basically the perspectives of architects differ. Okay. I told you about my friend who I'll invite. We worked on systems together. I was representing a team in Cisco and he was representing IT, different learning management systems. Uh, and we are great friends, but we also argued, hey, Mani, just recently I finished another project with him. I said, Mani, why should we do like this? Why not this way, right? So good architect. Can any student envision? How is the argument between architects decided? What are the parameters things would be decided? Anybody from Vijayanagaram or Gudlavaleru? Gudlavaleru is silent today. What about Aditya? The all uniform college, right? Cost and time. Cost and time are parameters. Absolutely. Ideal cost and time are parameters. There could be a performance cost. There could be a security cost. There could be a scalability cost because one type of architecture would lend itself very well to scale the system for future growth. Remember, there are some standard software engineering principles, right? Enhanceability, scalability, right? Maintainability, ease of use, cost of ownership, right? Uh, so there are different parameters now. When you have so many parameters in organizations, you always prioritize, right? Security is paramount. So whenever you're evaluating an architecture, it is not simply because the architects are experienced and they have egos. It's not a personality argument. It is really about arguing with the priorities of the business in mind. What is it's always business driven analysis. Okay. Imagine a standard scheduling system in a university. I don't think security is of paramount importance there, right? It could be something else, ease of use of allowing students managing all the payroll. A lot of authentication and authorization requirements come into play, right? Otherwise, a faculty member can go change his salary from, I don't know how much they pay in India now, 1 lakh rupees a month. They can go change, add one more zero and they'll start getting 10 lakh rupees. Okay. So architectures are evaluated based on certain parameters. Okay. Now, having said that, ultimately the guy with power wins. Okay. You want to be, it's like, there are some compromises. This is where the practical reality comes into play. There are certain compromises. Those kinds of things can happen too, for the sake of relationships. Okay. Okay. Let me move forward. Okay. Then we have this theoretical concept called architecture in the small and architecture in the large. So what you are doing for your project for this class is in essence architecture in the small, because you are doing a small project. Okay, so how you break your project down into multiple components is what that would be. Components like HR system, sales system, accounting system, and so on, financial system, and so on. That is really programming in the large or architecture in the large. Okay, but for the purpose of this class, the project that you're doing can be classified as architecture in the small. Okay, did I miss a slide there? I missed some slides there. Okay. So now why do we need architecture? Because again, all these diagrams, they serve one big purpose. Analyze that picture that you come up with from an analysis viewpoint, saying, for example, does it meet the requirements? It's not just does it meet non-functional requirements. Even functional requirements, you have to make sure it meets. What are non-functional requirements? These are the things like security, right? Security is a non-functional requirement. It is not doing any function, but you're ensuring that security is there. Authentication, authorization, confidentiality, right? And then you're also looking at, can it scale? Remember, I talked about scalability. Can it scale across multiple range of systems? Uh, do you want to add anything to that? I know your research area is software engineering.
Get back to you if anything is there.
Okay, okay, great. Okay. Students, by the way, this is a very important chapter. I'll keep it as simple as I can. Okay. Now, what type of diagrams we draw here? It's the same thing, right? If you know ER diagram, you can use it for architectural representations too. Okay. Um, that still works in the industry, by the way. But as you can see, there are always critiques, right? They don't show the types of relationships or the visible properties. So what you do is you add those things. Remember, how many of you remember when I was drawing an entity relationship diagram, one of the things I mentioned is I use arrows and I use annotation on the arrows, right? The theory of ER diagrams says there's no need to put arrows and there's no need to annotate arrows. But I do that because you want to add more semantics, more meaning to what you're showing. Okay. However, most of the stakeholders, they understand boxes and arrows. So they do serve a purpose, right? The diagram is good if the user understands it. The diagram is bad if the user does not understand it. Rule of thumb. Okay. It's kind of like this. It's kind of like a art, M.F. Hussain, our great painter, right? How many of you appreciate M.F. Hussein's art? Show of hands. Lot of us, right? By the way, even if you don't appreciate in a group setting like this, you have to who don't appreciate his art because they don't understand it. It's so abstract. So-called modern art, for example, for which people pay millions and millions of dollars. I see them here in museums. Wherever I travel, I go to museums, art museums with my son. Okay. And my son is looking at it and he's telling me what great art it is. He's getting meaning out of it and all that. Okay. Whereas I'm staring at it, it's the same picture. I don't get any meaning out of it. I don't understand it. I'm ignorant. So as far as I'm concerned as a stakeholder, whatever that artist was trying to convey, he lost me. Right. So same thing here, right? So whenever with him or her.
Sir, I have a small doubt here.
Chapandi.
Sir, I have a notion that the use cases are what is the use case is for the user. The same thing, the architecture is for developer. Is it true or false, sir?
Can you repeat the question again?
What the use case is for the user, end user, the same thing architecture is for the developer. It's not meant for the end user.
Oh, okay. That's a very interesting statement that you made, actually. Let's spend a few minutes on that. So let me mute you for a second here. What Tirmal Raugar said is, what is being made in that statement following, that users don't see the users, meaning the stakeholders don't see architecture diagrams. Only the developers see that. That is the assumption in that statement. Okay. Now, what I have seen in reality, though, especially since we are now into Murtigaru, you're smiling. It's a great question by Tirmal Rao
Sir,
garu.
actually, I have the same. Sir, how can I? Can you listen to me?
Chapandi. Yeah, Chapandi.
Can you my question is the same, sir. That's what I asked. Technically, what is the difference? I questioned you.
Correct.
The reason is the architectural diagram, none of the stakeholders will be looking into. Only the technical team will be looking into.
So that's what I'm saying. So you are making an assumption there that it's only meant for developers. But in today's agile world, right from day one, the fundamental concept of agile is the user is also part of the team for that entire 2 to 3 week sprint session. Right? So whatever you guys are doing in that sprint session, the user is seeing them anyway. Subsystems, right?
Then what is
So,
exactly the difference between these two, sir? Between the use case and
so
architecture and AR diagram?
correct. Got it. So what is the difference between? So let me write it here. Okay. Uh, let me create a blank slide here. Give me 1 second. I'll create a blank slide.
Maybe with an example, if you could explain, that will be better, sir.
I'm doing it right now. Okay. Difference between use case, ER diagram, students, you're all with us. Okay. Murtala asked, what is the difference between use cases? Okay. So let me give you an example of, let's take your own university system. Okay, Andy? Okay. This is actually a good example to start with. University information system. Okay, we are designing a JNTU information system. Got it? Okay, so there'll be a big Mutaru and other faculty members have come up with a 1-2 page problem, or even up to 10 pages. Problem statement. Okay. Now the problem statement says they list their existing problems: manual scheduling, conflicts in assigning courses to faculty, uh, uh, tracking faculty leave, budgets, okay, etc., etc. Okay, so they want to build this information system where it brings it all together. Okay, got it? That's 10 pages. So what do? I have a problem statement. So we said that I always focus on who the users of the system are and what do they do with that, correct? Okay, so I go here, I then create a next slide. Remember, I also told you whether you start with the ER diagram or use cases, it doesn't matter. They're comfortable with users. I'll say who are the users of the system. Who are the users? I would say students, faculty, HOD, registrar. Okay, let's put one more under 7 or -2. Okay, mute JNTUV. Let me mute JNTUV. Okay. Done. Okay, registrar, students, faculty, HOD registrar, uh, finance admin. Okay. And how did I come up with these things? Because when I'm reading the problem statement, remember I gave a rule of thumb, right? If I do not know anything about the problem domain, I can read the problem statement, pick out the nouns. Nouns become the potential users. Because in the sentence would say students would access this JNTU information system to enroll for classes, look up their grades, and so on, right? So these are users. Then if I were to go, remember we talked about users and use case models, right? So let me change the layout here to like that. So the use cases contain for each of the users. Okay, I'll say enroll in classes. Okay, pay fee, check their grades. You get the idea? Okay, that is use cases. Anyone has questions on that? Okay, so far I have not drawn an architecture diagram, remember? Okay, I have not drawn the architecture diagram. And let's also make another assumption here that the JNTU system, the vice oh, there's still some echo. Let me check. Ideal. Everybody is muted, Andy. There's no echo now. Okay, so you understand, right? So I looked at the problem statement, and of course, since I'm also domain expert in these systems, I know who are the users of the system. Remember, this is an enterprise-wide system. Architecture really is really at enterprise level, right? Okay. I mean, architecture in the small is a toy problem. Okay. Now we want. So I'll say users and use cases. Now I go to the duplicate slide. I'll call it diagram. So in my diagram, so I have to draw bubbles and arcs, right? So let's say for now I'll say ER diagram. So what are ER diagram? What is the concept of an ER diagram? Anything that is meaningful to your application entity, correct? That's how we define an entity. Entity is anything that you want to keep track of in your system. If right, so what are the things that I want to keep track of in my system? Let's put edit text and make it black. Do I want to keep track of faculty based on the problem statement? Because we want to keep track of their pay, their vacation, right? All those things, correct? So I make a faculty as an entity. Okay. Now I'll do a control C, control V for that because I'll be using multiple entities, right? They are in what is their GPA, right? Who is their advisor? What is their, whatever reasons are, who are their parents? In India, we keep track of a lot of things, right? That is entity. And then you have the budgets, right? Do you want to keep track of the budgets? Now, this is a questionable thing. I'll tell you why it's a questionable thing, right? And you want to keep track of your courses, right? Like, for example, what is the course name? Who are the faculty members who can teach the course? Now, why did I say budget is a questionable entity? Because what is it that I keep track of budget? The moment I ask, what do I keep track of budget? Because budget is a noun in the problem statement. But does it become an entity? Probably not, because budget is an abstract one. Right? You break down budget, then in that analysis, I'll remove budget for now. Okay. What are the other entities that you could have? I can think of one more entity for you. How do you get all the textbooks and all that for your students? Yep. Or maybe the students, you provide access to students to order through the portal, right? Order books, right? So those are entities. Any questions on that? So you took a problem statement through library. So somebody said, everyone through library, you order books through library, right? So you can actually, the moment you say library becomes an interesting entity too, right? Okay. So what are the things you keep track of about a library? The moment you, like how I removed budget. Budget is really not an entity, right? Would I ask any questions of budget? Hey, budget, tell me how much you spent on this. No, I won't. It's meaningless, right? So these are the guidelines. If you ask a question and if there's no answer to it, then it's not the right entity that you're modeling. Okay. That's why but when I initially start putting the entities, I don't pay too much attention to whether something is right or wrong. I'll give one classic example that I always give. In the context of ER diagram, faculty members are welcome. Blah, 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 somewhere. I say, oh, it's a noun. Let me make it an entity. Now, is city an entity or not an entity? Show of hands. Who believes that city is an entity? I'm seeing JNTUV picture. Is there any student there or faculty who believes that city is an entity? Then raise your hand. Do I see one raise of hand? Okay. Trimal Ragar raised his hand. Okay. What about students? Is city an entity? Okay. Learn. How do I answer that? There are no right or wrong answer. I say in my system, the JNTU system, information system that I'm developing, do I need to keep track of anything associated with a city? Do I need to keep track of anything associated with Kakinada? Do I need to keep track of anything associated with Vijayanagaram?
It
That
depends
is
on the
relevant.
business process, sir.
Exactly, right?
Depends
For
on the business
JNTU
process.
information system, I don't need to keep track of anything about Kakinada or Vijayanagaram or Hyderabad or anything like that. Okay. Census tracking, right? Every 10 years, the population anta. 10 or 20 or 15, I don't know what they do in India, where every 10 years they go to households and say, how many members are there in your household, right? How many of them are educated, all of those things. So for an application that is keeping track of population statistics, వాళ్ళని ఏమంటారో వాళ్ళని సోషల్ సైంటిస్ట్ అంటారు అనుకుంటా వాళ్ళని. Okay. వాళ్ళకి when you're modeling city, it becomes very important because it's a very interesting entity. At the very least, what is the population of the city? What is the crime rate, right? How many females are educated? How many males are educated? What is the average age of the population, right? What is the literacy level? So these are all that's
Also,
for
in the education analysis,
yeah,
normally the city depicts which district it is there and all. So for the statistical analysis purpose, we use the city, but normally for the not for the running process.
correct, exactly, right? So then if not an entity, then what is this? This is an attribute. What does ER diagram have? Entities, relationships, and each entity is
Yes, sir.
characterized by attributes, right? So
Right.
city is very likely an attribute
Yes, sir.
of
Exactly.
student, faculty, and others. Right? Now, same thing with library. Do I really ask questions of a library? Probably not. Okay.
Yes.
And then I annotate it. Assigned to courses. Now, by the way, this gets very interesting. I can go deep in this. So you are assigned to course. Okay. Let's say, and the faculty member can assign to many courses, right? How many courses the typical faculty member teaches in a semester?
2.
2. So M basically greater than 1, right? Greater than or equal to 1. Okay. And each course is taught by
1 faculty.
1 faculty. Okay. Let me. The abstract models, I give meaning to these arrows. I add more semantics like that. If I don't put arrows, I do not know how to read the relationship. Okay. And then the cardinality. I say faculty member assigned to many courses. Each course taught by reversing the assigned to by 1 faculty. That's how you read the ER diagram. Okay. Now it gets a little bit interesting before I show you the architecture model. Let me ask you a question. Can relationships have attributes?
Yes, of course.
Yes, of course, right? Okay, stop right there. Now, attributes. I want.
Will have also, sir.
Yeah, we'll have.
Most of
Now, give some examples in the community, put it there. Some examples of entities where you can have attributes on relationships. Okay. Because that has something to do with implementation later on. How would you implement those attributes? Where would you implement those attributes? You should have learned those things in your database class.
Yes.
I assume. Okay. Okay. So that is the ER diagram. Any questions? Somebody said voice is not clear. Is it clear now?
Sir, it is clear now.
Yeah. Okay. Great. So that is ER diagrams. So let me duplicate this one. Now look what happens. Okay. So what was the architecture diagram for JNTU information?
Sir,
I'll just call it
JNTUK information systems.
Yeah. Got it? Remember, that's where we started, right? Now what is the architecture for JNT information system? Very easy. I would still use my
Sir, it is JNTUK.
JNTUK. Okay. No, I just made it for full JNT only. I didn't want to be.
No.
Oh, okay. JNTUK. Okay, I got it. I understand now. Got it. Yeah. All these. That's true. సో నా రోజుల్లో జేఎన్టీ అనే ఉంది కదా నాకు ఇంకా ఇప్పటికీ ఆంధ్రప్రదేశ్ అంటే నేను ఇంకా 1 స్టేటే అని అనుకుంటున్నాను ఇక్కడి నుంచి
Of course, నేను కూడా అలాగే అనుకుంటున్నాను సార్ ఇంకా నాట్ ఏబుల్ టు swallow the
so of course there are any Telangana faculty members here. I have to say Jai Telangana also. Okay, don't get me wrong. I rag both people. So okay. Okay, going back here. So now we are coming up with an architecture diagram, right? So what did the problem statement say? The problem all those things are there, right? So now how do I break the complexity of that big problem statement? I take the key high level abstractions. So I'll say you have admissions system. You have financial system.
examination system.
You have scheduling system, right? I'll say
Examination. Staff.
exam scheduling system, right?
Right, sir.
Let me stop right there. Okay, I'll remove this arrow for now because that's right. So what did I do here? I basically said that, hey, you want to build an information system. Okay, and then I'll probably put one more thing called after all, university has employees, right? Do you see the difference between a ER diagram, a use case model, and an architecture diagram? Now, students, let me ask students. Students, do you see the difference between the three?
ఏమ్మా మీరు మాట్లాడలేదు మీకోసం అడిగా కనీసం ఇప్పుడైనా మాట్లాడారు.
అదే ఇవన్నీ మూర్తి గారికి తిరుమల గారికి తెలుసును. See, what we are doing here is we are trying to foster that interaction here, to bring it out and foster that interaction. It's not like they don't know this stuff. We all know this stuff, but this diagram, there's a big lesson to be learned. After that, I'll stop. The lesson here is we have the domain knowledge of the systems. We understand the entire university, how it operates. That allows us to come up with these abstractions. A JNTU Kakinada first year, second, third, fourth year students who have never worked in a university environment, it is very hard for them to think about these abstractions. That is why, as I said in the beginning, to become an architecture in a domain, it takes at least 5 years because you assimilate a lot of the meaningful abstractions there. But we first focus on, even as analysts, we focus on some kind of a high level architecture. And architecture is nothing but what are the main subsystems. That's all it is. Right? Now, within each of these systems, we would then do the use case modeling. We will do the ER modeling, and then we'll do further architecture. Remember, there's an architecture in the small. When you start off for architecture in the large, at some point of time, you have to do architecture in the small. That's where you are organizing your program components, right? So once you have the subsystems, each use cases, ER diagram, architecture. So that's why when Tirmal Raghav asked me the question, you would never use an architecture diagram to communicate with the user, I actually told him, hey, you asked a very loaded question. At a certain level of abstraction, we do, right? Who should, if I am the vendor developing this one, who would I show this diagram to? I would show it. Remember, I said there's a committee formed by JNTU Kakinada, which has Murthy Garu and Tirmal Rao Garu and a couple of others. I'll be saying my understanding is in your system, these are the main components, right? I'm actually using
It's a question, it's a paradox for me, sir. But I still go on with my statement. 80% of the time, I feel what is my statement probably is correct. Because
Yes,
for the developer, I need a detailed subsystem to develop the things. If the architect, as you said in the last class, that if the business analyst and the architect hired by the organization is the best thing the organization can do, then the developer job is very easy. Now, if
correct.
the architect is doing his job fantastic in a fantastic manner, and the business analyst has already done this job properly, then obviously these things will fall down in its own place, and developer will do his job, just a coding part, very easily. It's a cakewalk for him. So
In that sense, it is important for
Sir,
the developer.
sir, but I differ with him, sir.
Yeah,
Reason is, as the architectural, rather as the team given by the client, we need to essentially know how it is going on, sir. Because
okay,
at the client place, because being on the project, the client manager will always monitor the architectural diagram as baseline he will consider, and then he will be looking into the implementation. Because
correct,
if he is not satisfied with any of the programmers and all, he will fire them in 2 weeks or 3 weeks time.
correct. So if you get two architects in a room, they will argue. So here we have three architects in a room. Murthy garu, Tirmal Rao garu, and me. Are we agreeing on everything? We are not. Did you notice that? So Tirmal Rao garu's perspective is different, slightly different from Murthy garu's perspective, and my perspective is slightly different. And in this case, I have to be politically right. I cannot take sides because both are dear to me. So very interesting thing. I will continue this particular one next class, but I want you to ponder this before you come to the next class. Tirumalagar, what you told, architecture, let's say I take financial system. When I talk about architecting the financial system, what you just said is 100% accurate. Because that architecture that you come up within this financial system is given to the developers to implement. Because you as an architect would say, these are the interfaces to the other systems. You in your architecture would say, from financial system, the information flows to student information system. It's a double arrow only, actually, not single arrow. For convenience, I put one arrow. The data that flows between HR system and financial system. Like when you hire a new faculty, all its payroll information will flow into the financial system. You agree? So the architecture that you draw for the financial system will show all those interfaces. What is the data coming in? What is the data going out? And in the process, you would also tell the developer which interface functions should be visible, which should be private. Not all the financial system methods should be visible to HR system and student IS. Correct? You have the public, private, and all that. So all those call it class category diagram. Okay, there's something called category diagram that we use, which shows nothing but the what are the major subsystems, right? and what is the relationship between them. That's what category diagram is. So whether we call it architecture diagram or category diagram, all of them mean the same thing. All they say is what are the various subsystems. Now let us say if your task, instead of calling it a JNTUK information system, if I change the word, you're developing JNTUK financial system, then all these systems are not there. Interactive discussion between us. Okay. Anything else, Andy? You want to wrap it up for today, or should we continue? Murthy garu.
We can wrap it out.
Great. So Naku, action items for students is in the community where we have put some examples of entities where relationships have attributes. Okay, one small task for you. I would be asking that question in the midterm also. So if you do it now, you'll get practice. Have we decided on the midterm? Students, if I hope you have all gone and joined the community. For those of you who have not joined the community yet, I'm giving you time till next week. That is Thursday, October 8th to join the community. And if you do not join that day, I will be locking the community. So if I lock the community, you would not be able to join unless a faculty member approves. That also means that you would not be able to access all the slide decks and all. So whoever has missed, go ahead and join the community now. Okay. And next week, one more last thing before I conclude. Next week, in the classroom, students would be practicing some exercises on the concept that we have learned. So that way they are prepared for the midterm. Okay.